Welcome to Jail Tactics Devlog, the mythical legend of a vlog, documenting the epic that is Wasteland Warden. Now available to Wishlist on Steam. So I dove into Shader Graph pretty hard this sprint, and I thought I would just run through some of the stuff that I learned while messing about. The three effects I have implemented are bloom emissions to make the things glow, giving them shadows, and this cool water effect using normal maps. But first, what is Shader Graph? Well, it's a visual scripting method to write shaders in Unity. Shaders are scripts that calculate the color of each pixel rendered on screen based on the lighting material used. While most scripts run on your CPU, these guys are done on the GPU, which is important when you're looking at performance. Now, I normally tend to shy away from visual scripting languages because I would rather just learn the underlying syntax so I'm able to edit as a low level as possible, but Shader Graph seems to be a very impressive tool that Unity is going all in on. You also get visual displays at every step, so it helps a lot when dealing with something that is purely visual like this. Shader Graph is also available on the new render pipeline, so you'll have to use the template or update your current project if you are interested in using it. I'm using URP since my project definitely does not need the higher end rendering tools of the HDRP. So let's make a shader. In the Create menu under Shaders and your pipeline of choice, you can pick any of the different shaders that they have available. It does not really matter which one you pick, you can change the type later on. This is Shader Graph 10, by the way. This creates a shader graph object, and since the first thing we are covering is bloom, I'll call it Sprite Glow. You can double click to open the interface, which will only have the master node in it. This is split between vertex, which manipulates position, and fragment, which manipulates everything else. You can actually delete and add nodes here as you see fit, so they are very versatile, which seems to be a big push in Shader Graph 10. Over here you have your blackboard, which exposes variables so that you can give different values on different materials using this shader. Bloom works by setting the emission map to interact with post-processing light. So, say I wanted this little guy's eyes to glow to indicate his evil intent. To do this, we need to combine his sprite sheet with an emission map. To make an emission map, it's easy, as take your sprite sheet and turning it black and whitening out any parts that you want to glow. The whiter it is, the more glow you'll get, so you can make a nice hue around the light if you're gradiating it. So in the shader, we will expose two texture 2Ds to set both of our sprite sheet and our emission map, as well as a color so that we can change the color of the eyes later on in the code, when he sees the error of his ways and no longer glows red, of course. Now the name variable will be what we see on the material, so we will name the first one main text, which is what it's called internally, so I recommend you following the naming convention here. The second one we will call emissions, and the color we'll call emission color. We will see a reference field in here, which is what we will use to try to access it via code. So we will use the name with an underscore so it's easier to remember. Another thing we can do is set the defaults so that all of our previews work while making the graph. Later I would probably remove these since every material will start with these defaults loaded in. But lastly, we will switch the color to HDR mode so that we can make it much more brighter and get that bloom interaction that we're looking for. So we drop all these into the shader, and now we need to tie the textures to the sample texture 2D nodes. What this does is just expose the various parts of a texture. So we need to multiply the color to one of the color channels of the emission map. Since it's just a white indicator, it does not really matter which channel we use. I'm going to use one of the single ones just for performance reasons. We multiply them so that the white turns to the chosen color and add the results to the main text color channels. Now, we just need to tie this all to the master node, but before we do, there are some settings that we need to change. Over here in the main graph settings, I can change the type of master node it will be. I'm using the regular lit material, and I'll explain why later. So workflow does not really matter, it just changes how the light reflects off the object. But surface, we definitely need to change to transparent. Otherwise we'll see the transparent parts of the sprite and it will just show a full square. Now changing that gave us an alpha node in our master, which is important. It also gave us a blend option, which is not important since we want sharp edges for our sprites, which alpha will give us. Now I check alpha clip so that the shader won't render the shadow of the transparent bits, and enable two sides since I'm flipping my sprites. Now we just need to tie our emission map into the master emission node and tie the alpha of our texture to the master alpha node and save the asset. From here we can make a material that uses that shader. We can do that by right-clicking the shader graph and creating a new material. A material in Unity is like a model that stores lighting information for the shader and ties it to the object's renderer, whether that be the sprite or mesh renderer. So if we set the material to use the sprite sheet and emission map and then put it on the sprite renderer, nothing will happen. But that's because we are missing one step, setting up the post-processing in the game. Now, if you started with URP template, this will all be set up already, but if not, you'll have to enable post-processing on your camera and create a global volume, which is just an object with a volume component on it, then make a volume profile from the create menu and put it in the new volume object. So we simply drop this into the renderer in the material slots, and then we can add an override for a post-processing bloom effect. Here you can play with all the settings to get the exact look that you want. For me, I'm just going to put bloom threshold and intensity to 1. Now you can see that the eyes are subtly red, and I can go into the material and really crank up the color to make it bloom all over itself. So for shadows, I had to make this graph that used vertex colors and a bunch of magic to make shadows work. But when I upgraded to shader 10, it broke this shader. After trying to fix it for a while, I gave up and just switched to light master, so it acts as if it were a quad, and with the settings that we did earlier, it will cut out the alphas and you will have a perfect shadow. Unfortunately, this will be a little bit more of a performance hit, but my game is not exactly a graphical powerhouse, so I'm not too worried about it. So the last effect I wanted to show you guys is the moving water. Since I already covered the bassist, I can just go through and show you the nodes that I'm using in this graph. I'm actually using 2 moving normal maps that pulsate a bit to get this effect. Normal maps are texture data for 3D objects to show shadows on its surface. Each color pixel in a normal map tells what direction the surface is actually facing and therefore causes ridges and divots in the surface itself, when paired with a light source. Now, I have made a few of these maps, but there are also a ton of free ones online if you don't need anything very specific. So for the main normal, I'm using this map that I found online that I think is for this texture. But it also works great as waves because it's kind of got that diagonal pattern in it. And what I'm using for the second normal is actually just simple noise that I am using to subtract from this normal map to make it just a little bit more interesting to look at. Over here you can see that I'm using time, which will just go up linearly, and I use it to multiply with a float number so that I can control it a little better. I split it out. This is just the same number going to the x and the y value of a vector. And then from there, I put it into an offset of a tiling node, which then can control the UVs of the normal map. So here you see I've put in the normal map and I've set it to normal, so now it's showing this. And because of the time little setup I have here, it's actually moving slightly. And I'm doing the same thing over here, but instead of a normal map, I'm using just simple noise, which is just a random algorithm that produces this pattern. Down here, I'm using sine time, which is time that just goes in a wave. And then I'm using a remap node, which just makes it so that you can control the min and max a little bit better. And we put that into a step. So step just makes it so that any value that is less than the integer that's put in will not be visible. So when I put this normal map into here, any of the values of the pixel that's being represented here will not be visible if it's smaller than this integer that we're putting in here. So with the RAM op going up and down, it actually just eliminates some of the lower integers over time and then brings it back in. So what that does is kind of pulsate it a little bit. And then since you could still see the pattern pretty well, it was just going in and out. That's why I made this noise to come in here, and I just subtracted the noise from my normal map here, and it made it just a little bit more interesting. Then you put it into a normal strength so that you can control the actual strength of the normal, which will show how much shadow or light is actually there depending on this integer. And then you just slap that into the normal fragment, and it will be visible on your object that you make. And then all this stuff is just so that I could put in a sprite and manipulate the sprite's color. So that's about everything that I did with shaders on this sprint. I will definitely continue to toy with them. There's so many things that you can do. I haven't even started to dig into changing positions with them, but it's definitely a great tool, shader graph, and I highly recommend you looking into it if you haven't already. But with all that covered, today on Quick Tips with Chillin', we will be taking a look at Unity's Smart Search. The other day I ran into this problem where I could not find this wayward collider in my scene. The only way I could see a collider is if you select an object, but since I have a bunch of strange invisible objects all over the place, clicking on the scene does not reliably select things. So, I was looking for an easy way to find this fellow when I figured out that you can filter your hierarchy search, not just by object names, but by the type as well. So if you just type in collider, every object with a collider will appear, and I can just select them all, and boom, I found that sucker. This little revelation has seriously cut down my search time. So now it's time for Community Spotlight. We're looking at Full Moon today. Full Moon is a Metrovania where you are the Egyptian god Anubis as he explores pyramids and combats some dark forces. The fighting and art look great, and you can follow along the development done on his YouTube channel. He is making it in Unreal, and his devlog style is very similar to mine, so go check him out. He is also very active on Twitter and has been very supportive of me on both platforms, so thanks a lot, buddy. So that's all I have for you this time. Next sprint I plan to break open Blender and make some cool 3D pixel art, so subscribe if you want to see how that goes. And while you're down there, hit the like, tell me how bad my shaders are in the comments below, and don't forget to wishlist Wasteland Warden on Steam.